Hello everybody and welcome back to Algebra 1 from Prospect Charter School. Today we're going to be going over section 2.3, which is solving multi-step equations. In the previous two sections, we went over how to solve using addition, how to solve using multiplication, and now we are going to take the both of them and we are going to put them together and call it a multi-step equation. Now we already know what it means to solve, and we already know our definitions. But I'm going to give you guys a rule of thumb first. Our rule of thumb is as follows. So this is Mr. O'Neill's rule of thumb. Mr. O'Neill's rule of thumb. And Mr. O'Neill's rule of thumb for these is to get rid of addition, can you guess? Add. To get rid of multiplication, can you guess? You're right. You multiply. To get rid of multiplication, we multiply. To get rid of addition, we add. To get rid of addition, we add. To get rid of multiplication, we multiply. So let's go ahead and look at some examples to find out exactly how and why it works. Now, when we were originally doing things, we would use our order of operations, G-E-M-A. So when we are evaluating, we follow the order of operations from left to right. So this would be evaluating. But when we are solving, we do the opposite. God, I hate that word. We go backwards. We go from right to left when we're solving. So instead of doing addition last, we do addition first. Instead of doing multiplication next to last, we do multiplication second. Instead of doing exponents second, we do exponents second to last. And instead of doing grouping symbols first, grouping symbols are the last thing that we deal with when we're solving. Isn't that awesome? Hey. All right. With that rule of thumb and with this understanding of the order of operations, going from left to right for evaluating, right to left for solving, we should be able to figure out what our real two-step or multi-step equations do, or how to solve them. So we're going to begin with a really easy one. We're going to start with 10 is equal to 6 minus 2x. And we are going to be told to solve for x, of course. Solve for x. All right. Now, the first step is always asking ourselves, all right, which variable are we solving for again? In this case, we're solving for the most common variable ever, x, because, well, nobody likes the x being with people, and we prefer that they were alone for all eternity. All right, so how are we going to isolate our x? Now, if we remember our order of operations, GEMA, remember we're going from right to left, so we want to get rid of addition first. So what's hanging out with the x? That's addition. Well, if you said the 6, you were absolutely correct. So how do we get rid of the 6? Well, to get rid of addition, you add. Only in this case, we're going to be adding a negative number to make it go poof. We're going to be adding negative 6 to both sides. Now when I do that, on the left-hand side, our 10 suddenly becomes 4 because 10 minus 6 is 4. 6 minus 6 becomes 0. And now we're left with a conundrum. Mr. O'Neill, what do we do with that minus sign? Well, it just hangs out. What we can do to make it a little bit easier to understand is change this into plus negative 2x, and then everything will make sense from there on out. So whenever you see subtraction like minus 4, you can change that into plus negative 4, and it doesn't change the system at all. It just makes it, for some people, a little bit easier to see and understand. All right, so I'm going to change this to plus negative 2x, which means that when I subtract the 6 and they go poof, I'm left with negative 2x. So I have negative 2x over here. And now I'm still solving for x, so who's hanging out with the x now? Well, the negative 2. And, negative 2's, they're so negative that we don't even want them to hang out with our x's, because as much as we dislike our x's, we don't want them to have that bad of a life. We just want them to be horizontal, kind of like our x-axis. So let's go ahead and multiply both sides. Oh, I should use a different color here. We should multiply both sides by negative 2. That's the number that's in front of the x. Except that instead of it being a negative 2, we're going to put a 1 over it. Remember the reciprocal thing? So we're multiplying by the reciprocal of negative 2, which is negative 1/2. So I multiply both sides by negative 1/2. I get negative 2 is equal to x. My x is now completely isolated. We have solved for x. So note the order of operations, right? We started out by getting rid of addition, using addition. The next step, we used multiplication to get rid of the multiplication. So to get rid of addition, you add. To get rid of multiplication, you multiply. And when you're solving, it's the reverse order of operations. Easy as pie? I would hope so. So let's do another example, because a good example is worth a million words. No, because it's worth 1,000 pictures, and 1,000 pictures is worth it. Never mind. All right, that joke failed. Poor joke. Good old Gandalf stood there and said, "You shall not pass." Just like he does to really bad students. Teachers say the same thing. All right, here we go. We have to solve for Q. And no, we're not talking about the Star Trek Q. We're just talking about the letter Q. No, not a cue ball either. God, some people. All right, so we have Q divided by 15 is equal to, minus 1/5 is equal to 3/5. And I know what you're thinking. You're thinking, OMG, fractions. And something like for my life or something similar. Don't worry, fractions are friends, and here's a really easy way to get rid of them. If you really hate working with fractions, your first step can be to look at your denominators and say, all right, what can I multiply by to get rid of all of them? And I do mean all of them. So I never have to worry about them again. Well, you'll have to worry about them again at the end, but, oh well. For now, I would look at these and go, okay, well, 5 is prime. Can't do anything with it. But 15 is not prime. 15 is a composite of 5 times 3, which are 2 prime numbers. And so I would have to multiply by 5 times 3. Because 5 is in common to these guys, I don't have to add another number to multiply to them. I just have to worry about the 5 times 3, which is, of course, 15. So I look at it and I say, all right, fine. I'm going to get rid of the fractions. God. Multiply both sides by 15. And when I multiply both sides by 15, oops, here we go. Go back up. Thank you, sir. When I multiply both sides by 15, remember, the distributive property says that it goes to everything. Not just one piece of the side, but everything on that side. So it's going to go to the Q over 15, and it's going to go over to the negative 1/5. So I'm going to do, okay, well, 15 times Q over 15. 15 divided by 15 is 1. 1 times Q is Q. And then I do the 15 times the other one. 15 times 1 over 5. I do, okay, well, 15 divided by 5 is 3 times 1 is 3. So I have a minus 3 is equal to, and then I do the same thing over here. I have 15 divided by 5, which is 3, times 3, which is 9. Where'd the fractions go? They went away! Yay! No more fractions! All right, so what do we do next? Well, we got to get Q by itself, which means that we got to get rid of this negative 3. How do we get rid of addition? We add. Add 3 to both sides. And now we have Q is equal to 9 plus 3, which is 12. And shazam, we are done. We got rid of the fractions in one fell swoop, and everything else is beautiful. All right, you guys ready for your last example? I hope so, because here it comes. Our last example is solve for x. And we are going to be given that 6x plus 3 plus 8x is equal to 13. And actually, I'm going to give us one more example after this one, so I lied. Sorry. All right, so 6x plus 3 plus 8x. What do we got to do first? Well, first, we have to combine like terms. You always have to have all of your like terms combined first. If you can combine like terms, do so on that step, always. It will make your life a lot easier later on. So let's look for our like terms. 3. Does 3 have any like terms? Well, not on the left-hand side of the equal sign. Okay, what about 6x? Does 6x have any like terms? Well, on the left-hand side of the equal sign, it has 8x as a like term. So we're going to combine those two guys. Notice that we are adding a 8x to a positive 6, so then we would add them together. 8 plus 6 is, of course, 14. So we have 14x plus 3 is equal to 13. Now note we didn't do anything on this side of the equation, mainly because there wasn't anything to do. 13 is by itself. It has no like terms. It's kind of lonely. So let's see if we can't bring number 13 some friends. So to do that, we're going to have to first get rid of the items that are hanging out with the x in the reverse order of operations. So let's write down our reverse order of operations. We go from right to left. We start with addition. The 3 is hanging out, so we got to add to get rid of it. So I'm going to add negative 3 to both sides. And when I do that, I end up with 14x is equal to 10. Now we use the next step in the list, which is multiplication. So multiplication is 14, so I would multiply both sides by 1 over 14. You can also divide by 14 if you want. I just have a habit of multiplying by its reciprocal. So I multiply both sides by 1 over 14, and I end up with x is equal to 10 over 14, which can reduce. So we have x is equal to, let's see, 10 and 14 are both divisible by 2, which would give me 5 over 7. 5 and 7 are both prime numbers. They don't have anything in common. I have reduced as much as possible. My x is by itself. It is isolated. We are done. Stick a fork in us. We are done. Actually, no, we're not done. We got one more example. This last example is, hey, what happens if there's an x on both sides of the equal sign? Uh-oh. Let's look at 2x minus 4 is equal to 4x plus 2. And we are going to be told to solve for x. Oh man, how do we do that? There are x's on both sides of the equal sign. Well, what I would do is I would pick a side for the x's to go to. Pick a side for the x's to go to. So in this case, you know what? 4 is bigger than 2, so I'm going to be mean. I'm going to say 2, get over to the right-hand side. And 2 is going to be like, okay. So I subtract 2x from both sides. And when I do that, it eliminates all of the x's on my left-hand side of the equation. But on the right-hand side of the equation, I'm going to be left with 4 minus 2, which is 2. So I have 2x on the right-hand side of the equation. On the left, I have a negative 4. And on the right-hand side, I bring down the 2. So I have 2x plus 2. Now I can do the reverse order of operations. Good old Gemma. Or AMEG, in this case. So AMEG says addition first. Subtract 2 from both sides. Now note this is a negative 4. So a negative plus a negative is even more negative, right? Because if you're looking at it, we're on a number line. It says, okay, move 4 to the left. Okay, 1, 2, 3, 4. Now move 2 more. 5, 6. Bam, where are we at? Negative 6. Shazam. Negative 6 on the left. On the right, the 2's cancel. The positive 2 and the negative 2, it's like saying go to the right 2, now go to the left 2. Where do you end up? Back where you started. All right, so those go poof, and we're left with 2x. Again, going with ameg, or Gemma backwards, we would then try to get rid of the 2, because that's what's hanging out with our x. So to get rid of the 2, we would multiply both sides by 1/2. And then we'd say, okay, 1/2 times negative 6. We say 6 divided by 2 is 3 times 1 is 3. So we're going to have negative 3. Remember, a positive times a negative is a negative. So we have negative 3 right there. And then over here, we have 2 divided by 2, which is 1, times 1, which is 1. So we're left with just 1x. X is isolated. We have solved. All right, thank you very much. You've been a wonderful audience, and now it's time for you to do practice. Woo! Everybody's favorite time. All right, this one is going to be section 2.3, and this is going to be on page, hopefully it's on page 96, but again, books are very different. Numbers 1 through 17 odd. And then some difficult ones. 25, 29, 31 because it has fractions. So 31, 35, 37, which includes the distributive property. Yay, distributive. And 41 to do it again. And of course, we can't do anything without at least one word problem. So let's go ahead and look at 53, because word problems are great. 63, because that deals with word problems in a chart. And 65. All right. By now you're already making lots of noise, moving your books and shuffling papers and writing stuff down. So please try to keep it down in the classroom. You know, some people are actually trying to work. So be nice. Work through your homework problems. If you get done before the end of the class period, great! If you don't get done by the end of the class period, well, that's okay, because now you got homework. Always remember to ask questions. Good luck, and have fun.